Hi everybody. We are going to talk today about the path towards Spring Boot native applications. I am Sébastien Deleuze. I work at VMware as a Spring Framework committer. My topics are Kotlin, the web support, and GraalVM native. Andy, if you want to present yourself.
Hi everybody, I'm Andy Clement. I'm a director in the Spring engineering team at VMware.
Okay, so let's start. This is a standard statement because what we are going to show are work in progress, so you can expect changes from what we are going to say today. Today's agenda is the following. We are going to start talking about native executables and GraalVM. We are going to focus on Spring Boot native application. We are going to say you where we are in terms of support. A quick getting started guide. Andy will do a nice demo with the Petclinic sample, and I will talk about the roadmap. But let's start about talking native executables. So GraalVM is a project started several years ago by Oracle. It allows, among other things, to compile Java or Kotlin application into native executables that can run without a GVM. That's pretty useful to be able to create lightweight container images. There are two main benefits in doing that. The first one is instant startup. It allows to have a scale to 0 for your application. That means that you only pay when your application is used. It's basically serverless for any kind of workload, including regular web applications. And that's a good fit with Kubernetes-based platform like Knative. It allows also to have reduced memory consumption. We measured that 3x to 5x memory reduction in terms of RSS memory, which is the total amount of memory consumed by the application. It allows cheaper cloud instances, and it's critical for systems split into multiple microservices. While those new capabilities are super exciting, we need to keep in mind that the GVM and native executables compiled with GraalVM provide different trade-offs. So while native is pretty good in terms of instant startup and low memory footprint, it provides slower performances. This point is currently improved, and you can expect improvement in the upcoming versions. In terms of maturity, obviously, the GVM is much better, but GraalVM is maturing quickly. And in terms of build time, it's a clear difference between the two approaches. Native executables take a long time to compile, and it consumes a lot of resources. The key differences between GVM and native are the following. When you compile a native application, there is a static analysis of your application from the main entry point, and basically everything not explicitly used is removed. There is native configuration required for reflection, proxies, and resources. The class path is fixed at build time, but that's almost already the case with typical Spring Boot application use case. There is no class lazy loading like in the GVM, so everything shipped in the native executable will be loaded in memory, hence our focus on optimization at build time. There is also some code that will be run at build time. Some classes can be optionally configured to be initialized at build time as an optimization. I think GraalVM native is a source of inspiration for the whole GVM ecosystem, and also for the Java platform itself. There is Project Leiden that has been recently announced by Oracle. It's a different project from GraalVM, but it will bring this kind of ahead-of-time native compilation to the Java platform and to the JDK. Let's now talk about Spring Boot native applications. I tend to think that this GraalVM ahead-of-time native compilation is a good fit with a Spring Boot standalone deployment model, especially for containers. Compiling your Spring Boot application, like any others, to a native executable will require reflection, proxy, and resources configuration. But I have a good news for you. The Spring team is doing most of the hard work. So really our goal is to support the compilation of existing or new Spring Boot applications to native executables unchanged. Here is a quote from Thomas Vosvinger, the GraalVM founder and project lead, who said, "We are excited about the great partnership between the Spring and the GraalVM engineering teams to support native ahead-of-time compilation for millions of Spring Boot native applications. This is a game changer, enabling low memory footprint and instant startup for this workload." I would like to thank Thomas for the great partnership that we have. We have a very efficient collaboration, and my hope is that it will continue the upcoming months and years. So in Spring Boot ecosystem, to leverage this new native application runtime, the typical way will be to leverage Spring Boot container image support. So you will configure your Maven or Gradle build to trigger native compilation, and then you will just run a Maven Spring Boot build image or Gradle boot build image like you do for a typical GVM application. And using Paketo build packs, which has now preliminary support for GraalVM native applications, you will be able to create very lightweight containers. You can see here that we have a very small base image for the OS. So that's Ubuntu based, but consisting of only 7 packages optimized for security and size. And the image size is less than 20 megabytes. And on top of that, we have the native application. So this is a regular Spring Boot, Spring MVC, Jackson web application compiled to native, and its weight is less than 50 megabytes. So you have a total image size of 67 megabytes, which is pretty small. Andy?
Thank you, Sébastien. So let's take a look at where we are with these projects now, and then get into a little bit of how you can get started using these things. So first, a little bit on timeline and where we are. If you looked at these projects about a year ago, if you looked at the Spring support, you would have seen a lot of READMEs with a lot of gotchas in there, a lot of things you had to work around. If you see this exception, you need to do this. If you include this dependency, you need to exclude this transitive dependency. It was a little messy, but we've worked really hard with the GraalVM team over the last 12 months to fix as much of that as we can. So things are much more likely to work out of the box right now. At the same time, we've been working on the Spring GraalVM native project. This is where we incubate our support for Spring. And incubate, we're going to get into that project details in a minute, but incubation can tend to mean other things we could do that make Spring more amenable to native image compilation. And as we prove out those research topics, we push them on down into Spring Framework and Spring Boot. So the fact that we're a little way into this is telling you that we've already started pushing some stuff down into Spring Framework and Boot. If you look in those projects, you will see native image support is in there, but there is much more to do. So if you have an issue with GraalVM, I encourage you to go and check out their projects on GitHub. We have our own label there. It's not green. We need to talk to those guys about making it green. If you have an issue, go and have a look, because somebody else may be hitting it. There may be a dev build available with a fix in already. They're very responsive on there. They may be looking out for a test case, and maybe you could provide it to help those guys. And then alongside that, we have our project, which lives in the GitHub org Spring Projects Experimental. I encourage you to take a look. There are many, many samples in there to play around with, and there's comprehensive documentation on how to use it. But what is Spring GraalVM Native? It's the place where we incubate the Spring Boot support. Basically, there is a plugin in there for the GraalVM Native Image Builder. And the job of this plugin is to analyze your boot application, trying to compute the most optimal configuration. What does that mean? It means it takes a look at your Spring components and your auto configurations, and it works out that, oh, if you're using this feature, you need reflective access to this, or you need this accessible as a resource, or this accessible as a proxy. It computes that information for you and passes it on to the native image builder, so it includes the right things in the native executable. The challenge we face is that we're doing that in a static context. So we have to analyze your app without running it. So that can be difficult, and sometimes we have to make a decision. We can't tell if you're going to use something or not, so we kind of have to include it just in case you do. And if you don't end up using that, then that was a waste of time in the image. We've made great improvements on this, but there is still more to be done. I'm going to show you some numbers later. At the same time, we play around a bit with your application, trying to make it more optimal as a native image. There is a feature in Spring called auto configurations, and on that you can put a conditional on class annotation. So this auto configuration will only fire if that class is around. Now, as Sébastien said, when a native image is built, the class path is fixed. No more classes can be added after that. That means we can eagerly evaluate conditional on class annotations and throw out these auto configurations at image build time, so they don't form any part of the final image and you pay no cost in going to find out that they're not actually usable. So we try and give you a more optimal image from that point of view. We also do some work on compatibility. GraalVM supports a mechanism called substitutions. They allow you to patch classes as you build the native image. And there's a couple of reasons you might do that. One is that GraalVM doesn't support everything right now. For example, the method references stuff is a work in progress. And so you may need to patch a class to temporarily work around that problem and offer an alternative code path from the method reference. Also, and I mentioned this before, this is an incubation project. So we try things out in substitutions. Like, what if Spring did things this way? Does that create a more optimal image? So we do things like experimenting with how the logging system is initialized in Spring. Can we create a substitution that does it better? If it works, we push that on down into Framework and Boot. We don't like using too many substitutions. Effectively, you've got your beautiful application and you've tested it with your beautiful tests. And just before you build the native image, we patch it so it's something different that you didn't test. That doesn't feel great. So we incubate these substitutions, but we try to get rid of them over the long term. We've just released 0.8 of this if you want to try it out. You'll need GraalVM 20.2, which recently came out. And you'll need to be on Spring Boot 2.4.0, a latest milestone. I think it's around M2 as I write these slides. And the aim is that 0.8x releases will then follow Boot 2.4 through to its GA at the end of the year. This release has got significant footprints improvements. I have some numbers later to prove that. And at the same time, we've added support for a wider range of technologies. So Spring Boot actuators now work, Spring Data is working, a lot of the data flavors, including R2DBC is working, there's wavefront support. And if you want to dig into that serverless use case that Sébastien was alluding to, scale to 0 functions, there is a function AWS sample driven by Spring Cloud Function that you can go and play around with. There is a new experimental functional mode that may offer even greater gains in terms of reduced memory usage. But I'm going to let Sébastien talk about that at the end. And then finally, we're trying to make it more friendly in how you use this thing. Last year, it was all around the bash scripts, which are not great. This year, we're much more friendly to build systems. So I'll show you the snippet that you need to use to create those container images that Sébastien showed before, and how easy it is to integrate into your build system of choice. It's not just Framework and Boot. We've also working with the Tomcat team, and we have created, it's in the experimental group right now because we're still baking it, but there is an artifact called Tomcat Embed Programmatic. This is a cut down version of Tomcat that is optimized for native image analysis. So the GraalVM native image is analyzing the code paths within here. It can do a much better job with this artifact and throw much more away. And so if you use that, you'll save 3.5 meg RSS. Now, is that a big deal? Well, if you're running a regular app on the JVM using a few hundred megabytes of memory, 3.5 is a bit lost in the noise. But if you're using native image executables, they tend to run much lighter, much smaller. Sébastien showed one earlier that was a much smaller image. And at runtime, these can tend to consume like 100 meg or down to 50 meg even. So suddenly that 3.5 meg is quite a serious saving. It's not fully baked yet, as I say. You can play around with it. We use it in our samples if you want to take a look at it. There are other options. You can also specify to GraalVM native to save memory and other chunks of RSS. I encourage you to check out the docs to learn more about those. So that's where the projects are right now. But how do you get started if you want to go and play with this right now? So you need to be on that boot milestone, the latest one. So make sure you're on at least 2.4.0 M2. You do need to update your configuration classes. You see this proxy b method equals false. You do need to add that to your configuration classes to stop Spring from creating cglib proxies. GraalVM only supports JDK proxies in native images, so we need to turn it off. So right now I've shown it on Spring Boot application, but you will need to add it to all your configuration classes. You don't have to worry about the portfolio projects, the Spring ones. We've gone through those and added it across the code bases there, but you do need to do it in your app. We are looking at a much better way to do this in the future, so you don't have to worry about it. This is how you integrate into that Spring Boot container image support. Just put this snippet in your Maven POM, build pack boot native image true. That will activate that feature. And then the final thing you might choose to add to your configuration is Spring GraalVM native itself. If you use the build pack, it will give you a default version of that library, but it may not be the latest. So if you include a dependency in your own project, that will override the one from the build pack. Maybe you want to run on a snapshot. So that's how you override it. And when you've done all that, you're ready to go. So there's no bash scripts here anywhere. So fire off that Spring Boot support for container images, MVN Spring Boot build image. It takes about 60 seconds in the case for this example. Times can vary wildly, and that will give you a Docker image. Key benefit here is that you don't need GraalVM native local install, so you don't need to download Graal and put it on your machine. The build will happen in a container and produce a container. Now we're messing with containers here, so you do need to have Docker installed. And then run it however you run your container images. Docker run here, there's Docker Compose too. Here we've done some port forwarding so you can play around with it locally. And you'll see we get a Spring app starting with 50 millisecond startup time. If you're not yet using Docker, don't worry, you can build native executables without using Docker. You would use a snippet a bit like this. So this is using the native image Maven plugin provided by the GraalVM team. There's one bit of configuration you have to provide, which is this main class entry point to your application. Other stuff can go in here, like if you want to tweak the name of the resulting executable, that would go in here. But the bare minimum, you need to tell it where your application can be found. You'll see we've wired this into the packaging phase of our app, but we tend to wrap this in a profile because you don't want to run it every time you do a package because it takes a long time. So here I wrapped it in a profile called native, and then we just nvn-p native clean package, takes that same 60 seconds and gives us an executable. Now, for this to work, you do need GraalVM installed locally, but you can grab it for Linux, Mac, or Windows easily, and it will produce you an executable for the OS that you're running it on. It won't give you executables for the other OSs. Now, I've seen some teams have success with this who were working on CLIs written in Spring Boot, and they wanted a super fast, snappy quick starting CLI. So they would drop that Maven snippet in, and we're able to get an executable out easily. But I realize that's all slideware, so I'm going to show you some code in action now. So I am in the Spring Graal native project, and you'll see that we have many samples that you can go and have a look at later. We're going to look at one quickly, the command line runner. This is a very simple project. It's almost a sanity test. And you'll see all it has is one bean, one component that is a command line runner bean that just prints out a message. But the aim of this project is to just verify that annotation-based configuration, that key cornerstone of Spring, works with native images. I'm not going to show you a build of it because watching it for a minute doing nothing isn't very exciting, but I am going to run it just to show you that you do get that. Well, it's 30 milliseconds here startup time. It really is instant startup. But let's look at a bigger sample, something real. So let's jump over to looking at Petclinic. So this is Petclinic with a MySQL database. And yeah, we're still in the sample, so I encourage you to go and have a look at it. I just want to look in the POM and see that it's done those steps that I talked about. So it is on a milestone build of Boot 2.4. They've chose to include here the version of Spring GraalVM native. Remember that overrides the one in the build pack. And then it also has that build pack code plugin down here. It's got that boot native image true. This one is choosing to supply some extra options, and these can be options for the Spring GraalVM native project. So remember, I said there were other flags to remove other stuff to save memory. There is one to remove YAML support, which maybe you can do if you're not using YAML. And then the second option is to native image builder itself. It's saying, I'm going to use more security facilities here, so we need that support built into the image. Now, I'm not going to make you watch that build either. I've done one earlier. We're just going to have a quick look through it. So this is a Maven build, and you see that build image step. The Spring container build image stuff. Starts pulling in the native image build packs. And there's a couple of things to point out in here. One is this line here. So if there is a problem, you can pull out the native image command that was run inside that container and then use that to debug locally if you're having issues. Here we see, of course, ASCII art for Spring GraalVM native. This indicates Spring GraalVM native's kicked off and it started analyzing your application. And then finally down here, just before it finishes, you'll see the image build times. It tells you times about every stage of the process, but the key one is here. So this was 3.5 minutes it took to do this build of Petclinic. That may seem a long time, but believe me, it's better than 12 months ago. And then the end result is you have a Docker image for that Petclinic application. So how am I going to run that? We have a Docker Compose file in this sample. It just helps get organized with the database we want to run. I'm already running this component, the MySQL server, but I'm going to start up the Petclinic with Docker Compose. See how fast that starts up. So that was 170 milliseconds. There is some variability in this. Yeah, 50 milliseconds, 160 milliseconds. Just to show you that is real, let's jump over and exercise it. You see it's just standard Petclinic. It just so happens to have a characteristic that it starts instantly. But let's get into some numbers, some serious numbers. How does that compare? So here I'm comparing the executable I just showed you against what would happen if you ran the application on just as a JVM app on JDK. So you can see there's a clear trade-off here. We are trading build time for runtime. If I was just doing a regular build of a executable jar file for this app, it would take 9 seconds. But if I chose to build a native image of it, suddenly it's taking 194 seconds. What's that, three minutes or so? But the trade-offs, the benefits are massive. Look, when it runs, that RSS number, that all the memory of the process is down from 417 meg to just 100 meg, 75% reduced. And the startup time is down from, not too bad, 2.6 seconds down to 150 milliseconds. So they're massive savings at runtime. Just to show you some other numbers, this is comparing like where we were a year ago to where we are now. That command line runner sample I had, that remember that very simple app used to take 90 seconds. Now it's down to less than a minute, 50 seconds. The executable size is down by more than half. The memory size is down by 5 meg. I mean, there is some point here where we do need memory to do something, so it's not going to get to 0, but we're getting pretty low now on the amount of memory required for these apps. Another couple of samples you may choose to play with later. There's a Netty-based one, just a very simple Webflux endpoint with a Netty container. Build time's down from 3 minutes to 120. Executable size down another almost 50%. Memory down another 50%. You can see a pattern here. And the other sample, the Tomcat one, using that Tomcat programmatic dependency I talked about, build time's down from 3.5 minutes to 1 minute and 7 seconds. Executable size is down massively by 60%, and memory's down by another 27%. So you see, things are looking good after a year. And I don't mean to present these numbers on the right as we're done. There is much more to be done, and some of what Sébastien will show later will show you how we might get there. And maybe there's a slide next year where these numbers look a little bit too high. Now, Spring GraalVM Native understands your Spring applications. That doesn't mean it understands everything in your app. You may be using third-party dependencies that it's never seen before. So you may need to supply extra configuration for those. How do you do that? Now, it's fine to supply manually created configuration and use Spring GraalVM Native. They will work together to create the total configuration for the project. And the way this works is that you create these JSON documents with a particular name in a particular place. For example, in the metainf native image folder, a resource config.json. A native image builder will be looking for these files with these names in these places and pick them up and use them. There are multiples to provide. I've shown you a sample here of the resource one. It uses patterns, so my resource.star, and that means anything on the class path that matches this pattern will be included in the native image. Similarly, you can create a JSON document for reflection, what types you're reflecting on, what methods are you calling by reflection, and proxies. So what types, what groups of types do you need a JDK proxy for in the image? Crafting these JSON documents can be a little bit painful because of that build time. So you hit an error, make a change, wait 3 minutes for a build, hit the next error. It's quite a slow process. There is a way to automatically collect and create this configuration with the GraalVM agent. So it's a Java agent that you attach to your, when you run it in Java mode, and it keeps an eye on what you're doing, notices reflection and resource, and creates these JSON documents immediately for you ready to use. There is way more documentation to cover this than I can talk about here. So you can look in the GraalVM docs, or you can look in our project documentation, which goes into detail on how to use this kind of manual configuration with Spring GraalVM Native. So with that, you should be ready to go. So now I'm going to hand back to Sébastien, who's going to look a little bit further ahead about what's coming.
Thanks, Andy. So yeah, let's talk about the future. In December, we plan to release Spring GraalVM Native 0.9, and that's a pretty important milestone because that will be the first release with beta support. It will be based on Spring Boot 2.4 and GraalVM 20.3. We plan to target supporting a subset of starters, and breaking changes will happen, but we will provide upgrade paths. We plan to provide wider support, supporting interesting starters like Spring Security, Spring Batch, and we plan to provide development-oriented container image in order to allow debugging with GDB, for example. We are going to increase next year the level of support in the various 0.9.x releases, so expect more starters being supported, for example. And I would like now to talk about an hidden gem that has been in Spring Framework since 5.0. It's functional bin registration. So functional bin registration is pretty interesting for native images, and I'm going to explain why. So at the left, you have an annotation-based bin declaration using add configuration classes and add bin methods. That's pretty easy to read for a human, but for a compiler, and especially for native image compiler, it's pretty hard to understand that will be used to create some bin instances and etc. So at the right, you have the functional equivalent. So it's a functional interface application context initializer. And in the implementation of the initialize method, you can see that we are calling application context.register bin, and that take in parameter a lambda that can be analyzed pretty well by the native image compiler. So basically, native image compiler can understand this configuration without requiring additional configuration. And so that's pretty great in terms of compatibility and in terms of footprint. So what if we were converting automatically add configuration to functional configuration in order to allow you to benefit of this optimized footprint without having to change your programming model? And that's basically what we have done with Spring Init. So Spring Init is a project that we have been creating. We created that 1 year ago, I think, and it's a project that allows to convert add configuration to functional configuration automatically without changing your programming model. Native applications love functional configuration, and you can see in terms of figures, we observe close to 50% of improvement in terms of memory consumption. So this is really a typical Spring Boot plus Spring MVC plus Jackson and Tomcat sample. And with the functional variant, which does not require changing the code, but that's really an automated conversion, you can see that it is really more efficient. So we plan to leverage this kind of automated transformation at build time. In addition to this configuration conversion mechanism, we plan to support add configuration and add Spring Boot application annotations without CGLib proxies in order to support your Spring Boot application without requiring changes like that. And we would like also to automatically set optimization flags when relevant. Spring Boot 3 based on Spring Framework 6 is expected to provide first-class support for native applications deployment, as well as an optimized footprint on the GVM. So we are coming closer to the end of the talk. I would like to share a few takeaways with you. I think Spring Boot native applications are a great way to build lightweight containers. You can try it now using Spring GraalVM Native 0.8, which is based on Spring Boot 2.4 milestones. We encourage you to contribute support for your favorite starters, sending us a pull request. We are going to have a beta support in December with Spring GraalVM Native 0.9, and we will increase gradually the support in subsequent 0.9.x releases. And last point, our upcoming first-class native support will come with Spring Boot 3 and Spring Framework 6, but you don't really need to wait for these versions. We will provide a great support using Spring Boot 2.4 and 2.5 after that, and Spring GraalVM Native. Okay, let's talk about the question maybe. Okay, so a question about testing a native image. So I To be honest, I think the testing story with native image is still a little bit weak. So we plan to work on that, collaborating with the GraalVM team and maybe leveraging, we have some contributors on GUnit, like Sam Brennan in the Spring Framework team. So we really would like to improve the testing story for Spring applications, but also for regular GVM libraries, for example.
I'll take this one, Sébastien. So what tools are you using to collect those metrics that are presented in the slides? I'm afraid we're not using anything very high tech there. It's very much, we're on the command line using PS commands to grab the size of the images and the size of the memory use, those RSS numbers. There are scripts available in the Spring GraalVM native project, so you can take a look and collect the numbers of your own, maybe share them with us. Another question, can I just run my test with the agent to collect all the configuration I might need? Now, on paper, that sounds perfect because we said, as you exercise the application with this agent attached, it will compute what goes in those JSON documents. The problem is, if you're running it with tests, then what you'll do is you will be exercising test infrastructure. And what that's going to do is pull in those JSON documents, you'll also see test infrastructure entries, and there you do not want those in the native image executables that you create. So what you have to do, and what the GraalVM team have created, is there is a way to specify a filter file. So this filter, you create it and feed it in as an option to the agent, and it says, please don't include entries for my Mockito library or my test cases themselves or for JUnit. And so if you run with that attached as well, then it will filter them out, not put them in the JSON file. Now, how do you set that up? What goes in the filter file? If you go and look at the Spring GraalVM native documentation, you will find a lot of stuff around how to set that up for yourselves, so you can play around with it. It's quite straightforward to do. The only slight quirk is that you have to be able to categorize what your tests are with a particular kind of pattern so that they get excluded too.
Okay, maybe we can elaborate a little bit on the various typical other questions that we have usually. Maybe more details about this conversion from annotations to functional that I mentioned previously. This is something that is available as an experimental feature. So basically, if you are using Spring GraalVM native 0.8 and that you are specifying that the mode should be functional, or if you are using Spring Foo or Spring Init, which are two experimental projects that we have, it will be automatically enabled. And in that mode, basically, the feature that Andy describes provide less configuration in terms of, especially in terms of reflection. So it's important to understand that GraalVM support pretty well reflections, but it impacts the footprint when you add a lot of reflection configuration. And basically what we try to achieve by working on this strategy to convert annotation-based configuration into a functional one is to require less reflection configuration for the typical Spring Boot auto configuration. To improve the compatibility, because basically we don't have to maintain some additional ints, especially for the reflection one. And also it will improve the footprint because since the GraalVM native compiler will automatically understand the code base, the footprint will be lower. So that's really something that is currently experimental, but we think that's promising, and we will continue to work on that, especially given the fact that when you are using GraalVM native, there is more optimization to do at the build time, because like I said, everything you chip in the native image will be loaded in memory. So in that sense, it is a little bit less clever than the GVM that will load in memory only your classes when this classes is used. So you need to analyze and define at build time what is used and what is not used, and yeah, basically that's what we try to do with the optimization we are working on. And with this functional configuration, basically a GraalVM native compiler will be able to do the hard work alone. We don't have to help it with some additional configurations. So that's why we are working on that.
Tying in with that, somebody wants to know about the specific changes that go into Spring, those things we baked and pushed down. So we have, I mentioned logging system, but let's go a little more into the logging system and how that change came about. If you look at Spring Boot 3, you'll see that initializing the logging system is a series of strings in just regular Java strings for type names. Now, there's typically one string, and we do a class load for that. And if it's around, then the second string is the name of the logging system to use. And that's great. And you can look at the code and you know exactly what it means. But when GraalVM native looks at that code, it doesn't understand it. It doesn't know that that string contains a type name. So it doesn't know what you're trying to do. So if you look in Spring Boot 2.4, you'll actually see that we've rewritten that code so that rather than have we're trying to give hints to GraalVM native. So that we make a direct class.forName call for that string constant, and GraalVM recognizes that pattern. If you pass a string to forName, then it knows you're trying to load a class, and so it understands what's in the string. And then rather than the return value of that being another string containing the name of the logging system, we use a constructor reference. So suddenly we've gone from Boot 2.3, where we needed to supply reflection configuration for those strings to say, oh, this string is going to be treated as a type, that string will be treated as a type. We've gone to a place where we don't need any reflection because GraalVM native will understand that those are type references directly. So suddenly the images are faster, smaller, and going further than that, again, because that class path is fixed, if we have, say, an option of 5 logging systems, and the way we choose them is by which class is around, we can run that code at image build time. And that means that we can choose a logging system at build time. So then we don't need to include the other options in the native executable. We don't need to include the logic for determining which logging system to use. It's already been determined when the image was built. So I expect to see a lot more of those kinds of optimization coming as we incubate things in Spring GraalVM native and push them on down into Framework and Boot.
Yeah, we will add more optimization like that, and as we mature Spring GraalVM native, we will migrate progressively. During Spring Boot 2 and Spring Framework 5.3 development, more GraalVM native support, and the biggest parts of the support will be moved during Spring Boot 3 and Spring Framework 6 development, but that will be really a progressive step, progressive improvements. And so, yeah, you don't need to wait Spring Boot 3. Basically, most of the improvement will be available using Spring GraalVM native and Spring Boot 2.4 and later Spring Boot 2.5.
I guess maybe final question. Someone's asking about that proxy bean methods option and needing to specify that. You can't just slam it on all your configuration classes. There is a reason for it to be, for Spring to create those CGLib proxies. And that's so it can detect interbean creation calls. And if you're trying to enforce a singleton pattern, it won't end up creating too many beans. So it's not just a simple matter of going into your configuration and slapping it on and saying we're good. You do have to kind of be aware, and there is documentation in the Spring docs about this, what it means. You have to be aware of the implications. You may need to do a little refactoring, but there are standard patterns to switch around from doing those inter-method calls to create beans to instead use some form of injection. But it is important to pay attention there, and we've had to do that across the framework and portfolio projects, whether it's boot or security or batch. They've all gone through this notion of doing a bit of refactoring so the proxy bean methods can be set to false for all those configurations. So thank you for attending our presentation from Sébastien and I. There are 2 great presentations up next, continuous monitoring with the JDK flight recorder from Mikhail, and Project Loom, modern scalable concurrency for the Java platform. Ron is presenting that. If you want to see the full agenda, go and have a look on developer.oracle.com/dev/live-java and click the join button on the agenda to join either of those sessions. Thanks for watching.